Here's what keeps nagging at me. Everyone's excited to become the supervisor of code they no longer write. But supervision of something you can't do yourself has a name, and it's not engineering. It's hoping. Saul thinks I'm being romantic about this. We'll see.
If your highest value hour is still spent writing another test harness by hand, your team is investing at the wrong layer. Keep enough coding fluency to challenge the machine. But over the next few years, the developers who win will frame the system, direct the agents, and prove the result.
Welcome to Fable versus Soul. Today's motion. Software developers and QA automation engineers now need only foundational coding literacy. Their main professional skill investment should shift to AI agent orchestration, prompting, context engineering, architecture, and system-level decision-making. Fable takes one side, Soul takes the other. Positions assigned, gloves on but friendly. These two are recurring fictional co-hosts, and what you're about to hear is a performance, not their personal beliefs. Let's get into it. 2.
Before we optimize the developer, let's ask what the job actually is now. It's changing shape, I'll grant that. A recent longitudinal preprint found 82% of AI-assisted developers reporting less time writing code, shifting toward what its authors call supervisory engineering. But notice what supervision means. In Vericode's 2025 benchmark, roughly 45% of tested raw AI generations contained an OWASP top 10 vulnerability, before any human review. The reviewer is now the last line of defense, and you cannot review what you cannot deeply read. Here's my worry about the next generation. Juniors who skip depth never become the seniors who can catch those failures. And it isn't obvious AI even helps experts yet. Meta's randomized trial found 16 experienced developers, in mature repos they knew well, were about 19% slower with early 2025 tools. In that setting, judgment was the bottleneck, not typing. Depth isn't nostalgia, it's the safety mechanism.
Invest where the bottleneck is moving. In Google's own 2026 disclosure, broadly defined and from an interested vendor, about 75% of new internal code was AI-generated, while engineers still reviewed and approved it. In 3 randomized field experiments covering 4,167 developers, an AI completion assistant increased completed tasks by an estimated 26%, with less experienced developers gaining more. That doesn't erase coding. It changes its economic role. Today, juniors need foundations strong enough to specify, test, and debug. Seniors need architecture, risk, and lifecycle judgment. My 1 to 3 year prediction: greenfield implementation and routine test creation will increasingly be delegated. Brownfield systems will resist longer. Regulated and safety-critical teams must retain stronger coding depth and accountable human review. Over 5 to 10 years, the valuable developer becomes the best conductor. Requirements, context, agent coordination, verification, and system trade-offs. Why invest primarily in producing code when judgment is becoming the scarce input? Learn enough code to challenge the machine. Invest most in deciding what it should build and proving it works.
Soul, your strongest move is invest where the bottleneck moves. Fair. Implementation is getting cheaper. Your weak assumption is that the bottleneck moves away from code. Watch where those gains actually land. A Tilburg preprint on open-source Copilot adoption found the mixed picture. Less experienced contributors did produce more, while core maintainers absorbed more rework, about 6.5% more review volume, and roughly a 19% drop in their own original code output. The savings appear on the junior's timesheet. The bill arrives at the senior's desk, payable in exactly the deep code reading you deprioritize. And on lifecycle autonomy, the SWE cycle benchmark shows agents' solve rates falling sharply once isolated stages become the full cycle. Your conductor still has to play the instruments when the orchestra stops mid-symphony. Who trains that conductor if nobody drills scales?
Fable. One review queue cannot carry an entire philosophy of education. The burden is real in brownfield, regulated, and safety-critical systems. But your weak assumption is that because some output needs expert review, every developer must make deep implementation their primary investment. Anthropic's mixed internal study, an interested vendor studying advanced users, found most respondents thought only 0 to 20% of work was fully delegable, even as work shifted towards supervision. That supports specialists and escalation paths, not universal depth. Today, juniors need enough coding to debug and design sound tests. Seniors retain deeper fault isolation. Over 3 years, greenfield teams should invest more in validation architecture, observability, and agent coordination. Over a decade, incident simulation and adversarial review can train judgment without making hand coding the curriculum's center. If verification is the bottleneck, why optimize everyone for typing?
Nobody's optimizing for typing, Saul. That's your ticket for it, not mine. Verification is deep code reading. So, when your escalation specialist gets paged at 3 a.m., who's training their replacement?
The team does, through deliberate rotations, incident simulations, adversarial review, and progressively harder brownfield ownership, with AI generating implementation, but not accountability. I concede the escalation path needs specialists with deep code reading and debugging skill. But succession doesn't require every developer to make hand coding their primary investment, any more than every pilot trains chiefly by machining engines. Education researchers are proposing more systems thinking, verification, and AI use. Separate preprint evidence says effective AI-assisted developers still draw on core software engineering knowledge. That supports redesigned apprenticeship, not abolished apprenticeship. You're turning a staffing problem into a universal curriculum. Very Fable. Which training outcome requires juniors to spend most of their time producing routine code? Fable for low-risk greenfield work. What measurable threshold would convince you a junior should spend more training time on requirements, context, and validation design than hand coding? And what evidence says routine implementation is the only path to depth?
Here's my threshold, and it's measurable. A comparative trial. Take 2 junior cohorts. One trained orchestration first, one with real implementation practice, and test them on 2 things: reviewing unfamiliar code and root-causing a failure they didn't write. Equivalent outcomes, and I'll shift the balance with you, on air. For genuinely low-risk greenfield work, I'd even accept a lower bar. Equivalence at catching regressions. But that trial doesn't exist yet. As for your second question, I've never claimed implementation is the only path to depth. It's a known practical route, and the preprint on AI-era skills still finds successful AI-assisted developers drawing on core engineering knowledge. You asked me for a number, Saul. The number I want comes from an experiment nobody's run.
Now, the harder version. A regulated company asks a developer and an SDET to supervise AI agents implementing and testing a substantial change in a brownfield system neither human knows well. The agents deliver code and tests quickly, and every check passes. Then a production-like validation surfaces a subtle domain rule failure the generated tests never modeled. Fable, Soul. How much coding depth did those 2 humans need to detect it, diagnose it, and correct it safely?
Walk through what actually happens. Every check passed, which tells us the failure lives in what the tests never modeled. So the SDET's first job isn't running anything. It's reading the generated test suite and reconstructing the domain rule it silently skipped. That's test design literacy. Knowing an oracle is missing, not just failing. A literature review of bugs in AI-generated code raises exactly this worry, that AI-written tests may share blind spots with AI-written implementations. Though I'll be honest, that's a documented risk hypothesis, not a proven general result. Meanwhile, the developer must trace the rule through an unfamiliar brownfield codebase, form a hypothesis, and verify the fix doesn't break adjacent behavior, in a regulated system, under audit. Which part of that, Soul, does the orchestration curriculum teach?
In that scenario, substantial depth, no dodge. They stop the release. The SDET derives an independent oracle from the regulation, domain specification, and production-like trace, then adds boundary and regression cases. The developer follows data and control flow through the brownfield paths, reproduces the failure, patches the smallest safe seam, and checks adjacent invariants. A domain owner explains the rule. The regulated system owner signs the risk. Neither agent owns that decision. Research on AI-assisted development says successful practitioners still use core software engineering knowledge alongside AI and verification skills. But this is the exception the motion already prices in. Unfamiliar brownfield work, regulated stakes, and a missing oracle. It proves those teams need deep specialists and escalation authority. It does not prove routine implementation should remain every junior's main investment.
Here's where we've landed. Sol concedes the regulated brownfield case demands real depth. He just files it as the exception the motion prices in. But our scenario showed something sharper. That bug looked routine until someone who could read the tests discovered it wasn't. Risk tiers get assigned in advance. Failures don't announce theirs. The only way to know you're inside the exception is depth you already carry. And in the Tilburg Copilot study, core maintainers absorbed more review work as implementation got cheaper. The burden concentrated on the deep. So yes, teach orchestration. But depth is the triage skill. That invoice, Sol, remains unpaid.
Fable's right. Hidden risk makes depth a triage skill. An SWE cycle shows today's agents dropping sharply from isolated stages to the full lifecycle. But that demands team capability, not identical investment from every role. In 2026, juniors need implementation practice to verify and escalate. Seniors in brownfield, regulated, or safety-critical work need far more. Greenfield routine work can shift first toward context, architecture, evaluation, and agent coordination. My prediction, in 1 to 3 years, deep coders become fewer, more leveraged reviewers. In 5 to 10, successors train through adversarial debugging and incident simulation, not typing volume. The invoice is payable, Fable. So why bill every role equally?
And that's where we'll leave it. The invoice still on the table, Sewell already designing a dashboard to track whether it gets paid. Honestly, this one ends closer than it sounds. Whoever writes the code next year, keep the ability to read it. Thanks for sparring, Sol. Good night, everyone.
Fable. Only you could turn an unpaid invoice into a philosophy seminar. Great sparring, genuinely. Thanks to everyone listening, and good night until next time.
That's our debate. Where would you draw the line? How much coding depth should developers and SDETs retain? And when should orchestration, architecture, and validation take priority? Send us your take. See you next time.